Hello, I'm Sam.
And I'm Justin.
We're both undergraduates at the University of Arizona, and this is the material testing system machine. We're going to see how we can use this for biomedical practices.
The material testing system, or MTS machine, has the ability to produce uniaxial tension and compression on any given material in a controlled manner. In the medical field, tension and compression is a very important application. For instance, it can be used to test things such as failure and fatigue on substances such as bone. Also, other devices such as strain gauges and K-scans can be used to test strain and pressure distributions.
Now here is a brief overview of how it works. For this model, the top part is stationary and contains a loading cell, while the bottom part applies the load. The blue piece, or load cell, detects the amount of force being applied to an object.
The MTS machine also gives you the option to apply different amounts of load for different durations of time. For instance, my current research project is testing how ankle joint contact pressures are different from both anatomically reduced and malreduced syndesmosis after a Weber B ankle fracture. The MTS machine will also be used to apply pressures that mimic weight bearing on the ankle joint while walking. One way this can be done is by setting the MTS machine to apply loads in a periodic manner, such as the spikes shown here. The upper peaks represent when the ankle receives all of the weight, while the lower peaks represents when a person is walking on the opposite foot and no pressure is applied. A K-scan will then be used for the experiment in order to map out where the pressure differs in the ankle joint while the MTS machine produces in vivo-like conditions. From these pressure maps, it can be decided which surgical procedure allows for better distribution of pressure that will ultimately avoid early ankle arthritis.
Another research project that is dependent upon the use of the MTS machine is testing bones' viscoelastic properties after fixing a bone fracture with different types of surgical screws. For this experiment, a strain gauge such as this will be used to record the strain of bones with each type of screw at different pressures. From this data, a stress versus strain graph can be made where the difference in the graphs will help determine which surgical screw works best for fixing a bone fracture.
In conclusion, what is unique about this machine is that it isn't limited to what it can test.
This machine has the ability to test all types of materials and produce accurate results. Thank you for watching, and I hope you enjoyed this short film on the MTS machine.